Hi, my name is Josh Joseph, and this is my Physics 2211 Lab 4 report. So, in the introduction here, we got Newton's second law of motion and momentum principle. That's what we're going to be dealing with this lab, and the forces we deal with are gravitational force and spring force. We also deal with energy principle. So, the energy forces we deal with here are kinetic, gravitational potential, and spring potential. The summary results is that the computational model is very close to experimental model, but there's a slight deviation in values, and we're going to look into this a little bit more later. So the formulas that we deal with are velocity update, position update, force due to gravity, spring force, kinetic energy, gravitational potential energy, and spring potential energy, all of which we use in our code. And so in this lab, our system is going to be the spring of the block, while the surroundings is just going to be everything else. So when we look at the tracker, we can see uh, as the spring and the block starts to oscillate, we have the values recorded here, and we can see the clear oscillation model. And as we can see on the bottom, the X and Y positions of the block, we're going to use this value, put into an Excel sheet, and then using this Excel sheet, we can put into our code and compare the computational and the real model. So when we look at the code for a computational model, we can see it updated the ball's mass to be 0.402, which we got the pre-lecture video, and then the ball's position, the initial the position of the ball, we got it from we got it from the tracker, and then we know the ball was motionless when the video started. Now, as we continue, we can see right here, we have the gravitational constant, the K constant, and the L naught, all of which we got from the pre-lecture video. Then also the ball's position, L hat, and then got the S value from there. Then we also have the formulas, which we have for kinetic energy, gravitational potential energy, spring potential energy, and then we got the delta E. We got the total energy from that. Now we have T, which we updated to match the time frame, and then we have the gravitational force formula added. Then we also have the spring force added to this code, and then we calculate the net force by adding these two. Then using the net force, we calculate the updated ball's velocity and also the ball's position. Then we also find the L hat and the S of the ball at this time frame. Using this, we're going to find the energies during this time, which is going to be K. We got the K formula. Then the delta K, which is going to be the K we just calculated from minus K initial. And we just do the same thing for gravitational energy and spring energy. And then we add up the energies that we just calculated and then subtract it from the initial energy point. And so when we're looking at the graph, we can see that as the delta U increases, delta gravity delta U gravity decreases, and these two oscillate between each other. And we can also see that delta K oscillates at a lower amplitude, but it's still there. But then one key thing we need to note is that the delta E throughout this whole graph remains zero. And as we continue and look at the X and Y positions, we can see that they're very similar, but there's a slight discrepancy between the two values. We'll look into this a little bit more. So the first, what does it mean question was asking, was the energy principle satisfied? And since we know that there's no work applied, and since the energy graph, the orange line that represented delta E remains zero the whole time, the energy principle was satisfied. So what does it mean? Part two, it was asking us about the oscillations and how does this affect the lab. I calculated the oscillations the x direction to be 1.68338, and then y oscillation to be 1.519. And as we can see, there's actually a clear difference between the two. And so because of this, there's going to be the least of the discrepancy between the values between the computational and the experimental model. So we want our model to be more accurate. We just need to account for these differences. So conclusion, we use Newton's second law energy principle to compare the energy levels throughout the oscillation, comparing the real and computational model. Slight difference between the two because the changes in oscillation. To make our model more accurate, we just need to account for this. Thank you.